Okay, for this question, we're asked to write down the transformation that will transform the graph y equals p of x onto this graph here. So the first thing we can notice is our constant term, the negative 24, is the same. So we're not going to be dealing with a vertical translation or a horizontal translation. So the other option is we could have a stretch parallel to the y-axis. So that would be something of the form like this, y equals a times p of x. But we're not going to have that either. 1, because our constant term is the same, so a would have to be 1, which it clearly isn't, because our x cubed term then wouldn't match up. And well, if we did say have that x cubed, wanted to get times 8, well, it's not going to work for the negative 24 term, because we'd have to times that by 8, and also the negative 3 term times 8 is negative 24, which is not negative 12. So we're going to be dealing with a graph of this form, y equals p of a times x. And we can notice that, well, if we have 8 times 2x, we're going to get 16x. So if we just plug in 2x wherever we see x in our y equals p of x graph, then we'll end up with the graph that we want. So we can see that that works. So we have y equals p of 2x, well, that is equal to 2x all cubed minus 3 times 2x all squared plus 8 times 2x minus 24, and just expanding and simplifying that, so we get y equals p 2x, which is equal to 8x cubed minus 12x squared plus 16x minus 24. So now we just have to describe that transformation, and you might remember that if we have a graph of y equals, say, f of a times x, well, that stretches the graph of y equals f of x parallel to the x-axis by scale factor 1 over a. So let's just make a note of that. Okay, so what does that mean for our transformation? Well, so our transformation then, we have made a stretch parallel to the x-axis by scale factor 1 over 2. And that is our answer. So I'll just write that down. Okay, so there's our answer. And just to finish, I'll just bring up those graphs of y equals px and y equals p of 2x, just so we can see what's going on. Okay, so we've got y equals p of x in the red and y equals p of 2x in the blue, and we can see that the points on the blue line are half as close to the y-axis for the same y point as opposed to the red line. So for example, if we took the point x when x is equal to 4 on y equals p of x, let's say about there, it's just very rough, and we're going to have that same y coordinate at when x is equal to 2 on the blue line, which obviously makes sense because if we plug in x is equal to 2, or 2 times 2 is 4, we get p of 4, so that's going to be about, about here, say. Okay, so that point is half as close to the y-axis as for that same y coordinate on the red line. Okay, so that's our answer. We have made a stretch parallel to the x-axis by scale factor 1 over 2.